Welcome back everyone. Today I have picked up a good problem from current electricity chapter, or the electric current chapter actually, from Pathfinder, and it's from the section Build Up Your Understanding, question number 3, as you can see. So let's get started. The problem states that a ring of radius r equals to 16 centimeter is made of a wire of uniform cross section of radius a equals to 1 millimeter. Resistivity rho of the material of the wire is not uniform and varies with angular position theta measured from a fixed radius according to the given graph. Okay, so rho is a variable. It's dependent on theta. How much maximum resistance between a pair of points on this ring can be obtained? Okay, so let me draw a rough diagram first. So this is the diagram, let's say. This is the ring. Obviously this is a solid part of the ring. The material of the ring is here, and this thickness is given to us as 2a, obviously, because if this one is the cross section, its radius is given as a, so this thickness should be 2a, right? So let's say I'm taking a point a here and taking a point b randomly here, and these are the 2 points I have taken on the ring, and I'm supposed to find the equivalent resistance between a and b. So obviously there will be 2 resistance in parallel combination. One is this one, this part, and another one is this part. So the equivalent resistance of this 2 parallel combinations, the parallel combination of 2 resistors, will be our equivalent resistance across A and B, and we will try to maximize that equivalent resistance. So let me take the fixed axis here. Let's say this one is the fixed axis, the reference line. From here we are assuming theta equals to 0 degree, and let's say after a rotation of angle theta in clockwise sense, we have reached to point B. So obviously if we move around this reference line one circle, we will cover 2 pi angle, and we have given the variation of rho as a function of 2 pi. As a function of theta over 0 to 2 pi. Okay, so this one is our one resistance. Let's say this one is R1, and let's say this one is R2. So let's try to find out the value of R2. Okay, so what will be R2? If we take a small differential element here, right here, let's say small element, and this radius was R given, so this angle should subtend a small differential angle of d theta. So what will be this arc length? Now this arc length will be r d theta, obviously. So if I am trying to write down the resistance of this small part, let's say dr, or let's say dr1, let's say this one is dr1. What we will write? We will write rho times length of this segment, because current will flow along the circumference, right? Like this. Let's say this one is the direction of current. So we'll get rho times r d theta upon area of cross section, that is pi a square. So if we try to find out r1, that is the variation of theta from 0 to theta, we'll get r1 as integration of dr1, right? So we'll get r1 as 0 to theta rho r d theta upon pi a square, or we can simply write r, taking r by pi a square as a constant outside of the integration, is 0 to theta rho d theta. So this one is our value of r1 basically. And using the same analogy, we can write the value of r2 as well. So I will not explain in details anymore. I'll directly write r2 as r upon pi a square integration of rho d theta. The limit will change from theta 0 to theta. It was r1 because of this part was r1, and r2 is basically the other remaining part of the ring. So the limit of integration for r2 will change from theta to 2 pi. So these are the values of r1 and r2, and basically r equivalent or rab is the equivalent resistance of parallel combination of R1 and R2. So these two are in parallel combination, right? Parallel combination. So we'll write RAB as R1 times R2 upon R1 plus R2, and we'll try to maximize RAB. Now interestingly, if we observe that what is R1 plus R2, we'll get R upon pi a square, and integration of 0 to theta plus integration of theta to 2 pi of same function. So we can directly write accumulating these two terms as 0 to 2 pi rho d theta. And obviously this is a constant term. I mean whole R1 plus R2 has become a constant term. So just for sake of calculation, I'm writing it K. So we'll write RAB as R1 times R2 upon K. So basically what is the variable in RAB? Only the R1 R2 part. Denominator is constant. So we'll try to maximize RAB. That means we'll try to maximize R1 R2. And definitely R1 and R2 are two positive numbers, as these are resistances. So we'll use a simple theorem that we study in mathematics, that is AMGM inequality. So using that AMGM inequality, let me write it here. Using AMGM inequality, you can write that GM is always greater than equals to, oh sorry, that's a major blunder, right? I should not do this. AM greater equals to GM. Okay. That means R1 plus R2 upon 2. Arithmetic mean of R1 and R2 is greater than square root of R1 R2. Or you can say directly that the R1 R2 is lesser equals to, I'm writing here R1 plus R2 as K is basically less than K square upon 4. Means this one is the max value. Up to this limit R1 and R1 times R2 can reach. So it's almost done. So we were trying to find out RAB max. RAB max will be basically R1 R2 max upon K. That is nothing but K square by 4 upon K. It is K by 4. We'll put the value of K here. This was the value of K, right? So we'll put this value here. It's just, yeah, K was R by pi a square. Yeah, this will be R upon 4 pi a square 0 to 2 pi rho d theta. And leave this question here only, because this one is our final answer. If you check the answer key from Pathfinder as well, you will find this expression. And after calculating this expression, they have given the answer as 55 ohm. I have not calculated. I have just directly written the value after watching the answer from the book. Now how you can calculate rho d theta 0 to 2 pi? It's pretty simple, I guess. The graph is given and all the parameters in the graphs are shown. So you just calculate the area under this graph, and this area will give you 0 to 2 pi integration of rho d theta. So just calculate the area dividing into some rectangles, trapezium, triangles, and as per your convenience. It's pretty easy to calculate. So just calculate and put that area here, area under curve, and rest of the values R, A are also given. You'll get this one 55 ohm as answer. Okay, so that's all for today. Thank you, and stay tuned for some more interesting problems.